Hi guys, today I wanted us to go over some drift correction questions and I'm going to go through some solutions as well. The drift correction questions are common questions that people can get wrong on their PPL or CPL written, so I just gathered a couple examples that I wanted us to go through today. But first we're going to start with just briefly going over the correction methods. If you know the correction methods and you know the rule of thumb, you can totally skip through this, but I'll go over it super briefly so that you know what I'm doing when we're going through the examples. So first of all, we know that we have our double track correction method, right? We use this one when we're less than halfway from our destination. And the reason why we do that is I have a little example here. Let's say we have drifted, we're over here. We're less than halfway, right? If we were over here and we tried to use the double track correction, there's a chance we would actually just overshoot our destination, which is why we use this method when we're less than halfway. And how we would use this is if we know we've drifted 5 degrees, we would double that, and now that we know we've drifted 5 degrees, we would actually turn 10 degrees in order to regain our track. And as you can see here, if we only corrected for 5 degrees, we would be flying parallel to the track, which is why we need to double it so that we can get back onto our track. And then we also have the open closing angle method. We use this one when we're halfway or more than halfway because it's going to get us directly to the destination. So an example here, we've drifted 8 degrees, let's say, we drifted over, we're over here, so we're more than halfway. And we would find our closing angle to get to the destination. You add your opening, you add your closing, so 8 plus 12 would be 20, and in that case we would correct 20 degrees. We would turn 20 degrees to get to our destination, and we would turn to the right, for example, if we were flying this way. And then here, our rule of thumb, we all know, or we should know for these questions, that if you've traveled 60 nautical miles and you were 1 degree off for 60 nautical miles, you're going to be 1 nautical mile off your track, okay? So I drew this triangle here. Know how to draw this basic triangle because you're going to be drawing it for all the other questions so that you can refer back to it and you'll see why. So our ratio here is 1 to 1, okay? Think about it like this. If you were 2 degrees off, this is going to be 2 nautical miles. If this were 3 degrees, this would be 3 nautical miles. It's a ratio of 1 to 1. Now, let's say your distance is 30. Let's say you've traveled 30 nautical miles and you're 4 nautical miles off your track. How are you going to figure out how many degrees you've drifted? Well, let's think about our ratio here. How many times can 30 fit into 60? Well, 60 divided by 30 is 2. So we know that's a 2 to 1 ratio. So the way that you can figure out how to fill in the missing blank in this triangle is now that you know that ratio, we're going to multiply 4 nautical miles by 2, and this tells us that we have drifted 8 degrees. Okay, let's try it with this triangle here. We know we've traveled 20 nautical miles and we're 3 nautical miles off track. Let's think about our ratio again. How many times can 20 fit into 60? Refer back to the original triangle. 60 divided by 20 is 3. Okay, so our ratio is going to be 3 to 1, right? So how do I fill in this missing blank? Well, I'm going to take the 3, I'm going to multiply it by our ratio here, and I'm going to get 9 degrees. So we've drifted 9 degrees. Now, what if you were given the degrees, but you have no idea how many nautical miles you've drifted off? Well, let's use our triangle again. We have 20 nautical miles. We know it's 3 to 1, right? We already discussed that here. Our ratio is 3 to 1. But when we had our distance and we were trying to find our degrees, we would multiply, right? So in this case, we have to do the opposite. 6 degrees divided by 3 is going to give us 2. So in this case, if we traveled 20 nautical miles and we drifted by 6 degrees, we would find that we are 2 nautical miles off track. I hope that makes sense. We're going to move on to an example question here, and hopefully by the end of this, it'll be a little clearer. So you're traveling between 2 airports 100 nautical miles apart, okay? That's important. After 9 minutes, you've traveled 20 nautical miles. The time doesn't really matter, but we know our distance here. And you notice you've drifted 5 nautical miles off course. Okay, so we've drifted 5 nautical miles. How do you correct for this? Before I move on to the next slide, I want you to try drawing a diagram of what this would look like, okay? This is going to be super helpful during your written if you're able to visualize what's happening. If you have no idea how to draw a diagram, that's perfectly fine. I'm going to show you in the next slide, and then you can always try it on your own for the second question. So if you want to draw it on your own, pause the video here and try that out. Okay, so we discussed that we're traveling between two airports 100 nautical miles apart. So this is my distance here, 100 nautical miles, right? After 9 minutes, we've traveled 20 nautical miles. I'm drawing my triangle here, so this is 20 nautical miles. And I notice I've drifted 5 nautical miles off course. So how do we correct for this? Well, let's start with figuring out what method are we going to use, right? Are we going to use the double track method, or are we going to use the open and closing method? Well, are we less than halfway from our destination, or are we halfway or more from our destination? And from looking at this diagram, you can see we're less than halfway. So which method do we use for that? We're going to use our double track method for this, okay? So that means we need to figure out how many degrees did we drift, because in order to correct, we're going to need to double that, right? So that's our mission here. We're trying to find how many degrees did we drift. Well, what did I tell you we're going to do? We're going to draw our original triangle, okay? Sorry, this is a little wonky, but this is going to be our original triangle. We're going to compare it to what we see. That's 60, 1, and 1. And this is a 1-to-1 ratio, right? Now, let's talk about this. The first thing you're going to do is try and make this into a ratio. So, we know that 60 divided by 20 is 3. So that means our ratio is going to be 3-to-1. For every 60, we can fit in 20 nautical miles 3 times. And then, how did I tell you we were going to find this heading here? Well, we're going to multiply how many nautical miles we've drifted off track by that ratio, right? So in that case, if we multiplied 5 by 3, how many degrees off are we going to be? We're going to be 15 degrees off, right? So now, right, so we know what method we're using. We've determined how many degrees we've drifted. So now our final step is going to be figuring out how to correct for it. So let's say this is what it would look like if we didn't correct, right? We just keep flying away. Now, let's say you corrected 15 degrees. What did I tell you? We're going to fly parallel. And we are using the double track method. So in that case, we want to correct it here, right? Now, look, this might not be exactly where we end up, but this is just like a sample line. Now, if we were to correct another 15 degrees, we're going to regain our track. So the double track method calls for us to double this, right? We're going to double the 15 degrees that we've drifted, meaning that we are going to correct 30 degrees. So because of that, right, our last step is finding our correction, and we have found that we are going to need to correct 30 degrees, and then, for example, it might ask you to say to the right or left, and in our case, it's going to be to the right. Okay, so that's our correction in this example. Let's try another one. Okay, remember, we're going through the important stuff again. You're traveling between two airports 90 nautical miles apart. After 20 minutes, you've traveled 50 nautical miles, but notice that you've drifted 4 nautical miles off track. How do you correct for this? Okay, this time, you know what the diagram looks like. I want you to try drawing it on your own, so pause the video, draw this down so you can visualize it, and then we'll go through it together. Okay, so this is what your diagram should look like. This is the 90 nautical miles, right? This is our whole distance. And after 20 minutes, we've traveled 50 nautical miles. As you can see here, it's going to be the blue triangle. So we're past the halfway point. And you notice that you've drifted 4 nautical miles off track. So how do we correct for this? Remember, what's our first step here? Let's determine what method are we going to use. We have the double track method, and we have the opening and closing angle method. If we are more than halfway from our point, which method are we going to use? Yeah, we're going to use the opening and closing angle method. And in order to figure out how we're going to correct for this, that means we're going to need to determine now how many degrees we've drifted off track here, and then we need to know the closing angle, right, to our destination. So because of that, we are also going to need to find this angle here. So that's going to be our next step, is determining our degrees. Okay? So let's draw out that basic triangle again. Here's our basic triangle. 60 nautical miles, we have 1 nautical mile, and then our 1 degree. This is a 1-to-1 ratio. Now we're going to start with this triangle here. We have 50 nautical miles. So we need to figure out how many times can 50 fit into 60? Well, that's pretty easy actually. You just do 60 divided by 50. And when you do 60 divided by 50, you're going to find that it's a 1.2 to 1 ratio. Okay? So you can fit 50 into 60 1.2 times, if that makes sense. Now, remember, how do we solve this angle here? We know our distance here. It's 4 nautical miles. We know our ratio now. So what do we have to multiply 4 nautical miles by in order to figure out our degrees? We're going to have to multiply 4 by 1.2, right? So when we do that, we are going to find that we are 4.8 degrees off. Okay, perfect. So we have our one angle here. Now we need to find this one. So once again, we're going to figure out this ratio. But we're missing something. How long is this distance here? Well, we have our total distance 90. We know that we've traveled 50 nautical miles. So that means that we have 40 nautical miles remaining. Okay, sorry, that's like a really weird 4. Let me just like try that again. Perfect. And we already have our basic triangle drawn out here. And now we need to figure out this ratio. How many times can 40 fit into 60? Let's do the same thing we just did. 60 divided by 40 is going to give us 1.5. So we have a 1.5 to 1 ratio. Once again, we're going to take this 4 nautical miles and we're going to multiply it by 1.5. That's going to help us determine our angle here, which is 6 degrees. Okay, so we have our opening and we have our closing angle. We've determined what method we want to use. So our last step is going to be our correction. What is our correction angle going to be if we're using the opening and closing angle method? Well, we need to do 4.8 degrees plus 6 degrees, and that's going to give us 10.8 degrees, right? So in that case, in order to correct in this situation, we're going to need to turn 10.8 degrees, and then if we were flying this way, again, to the right. I hope that makes sense as well. Using the triangle to really visualize what's going on and remembering to draw your diagrams during the written is really going to help you perfect these questions. If there's something you didn't fully understand, feel free to comment and I'll be sure to get back to you. And I'll see you guys in the next video.